Okay, so today we are going to be going over Pythagorean theorem and getting more familiar with how it works, and then after that we will be doing multiple step problems to help us find the area of bigger figures such as these. Okay, so starting with Pythagorean theorem, we all know that a squared plus b squared equals c squared from what we've been going over. So we're going to start with this problem with 3 being a, 4 being b, and we're looking to find c. So we will start out with a squared plus b squared equals c squared. And we know that a is going to be 3, so 3 squared plus b squared, which is 4 squared equals c squared. Then 3 squared is 9 plus 4 squared is 16 equals c squared. 9 plus 16 is 25. 25 equals c squared. And then to get c, we'll do the square root of 25 equals c. C equals 5 feet. So your final answer for number 1 should be something like this. It's backwards, but 5 feet. And then for number 2, it starts out with 12 inches as B, and we have C as 15 inches, so we are looking for A. I can get this. Okay, that's just going to have to be backwards. But, so we start out with A squared plus B squared equals c squared, because we always start out with that, and then we alter the formula to find the missing side. So we know that we're looking for A because we have B equals 12 inches and C equals 15 inches. So we will subtract B squared from both sides. A squared equals c squared minus b squared. Okay, and then going from there, a squared equals 15 squared minus 12 squared. A squared equals 15 squared, which is 225, minus 12 squared, which is, hold on, let me get it. Okay, so 225 minus 12 squared, which is 144. Then a squared is equal to 81. Then we will find the square root of 81 to give us a. And then a equals 9 inches. Going back on how we know that we're looking for A is we have a perfect right triangle on our first two. So we always know that C is across from the biggest angle, so C is across from 90. And then assuming that this is a 30, 60, 90 triangle, because our sides are different, we have 30 degrees down here across from 3. And 60 degrees across from 4. Same thing on the bottom one. We have 90 degrees going across from 15. And then we would have 60 degrees going across from 12. And 30 degrees going across from A, which we know now is 9. So your biggest degree will always be across from C, which we know the hypotenuse C is always going to be the biggest number, and then the smallest number is always going across from the smallest side. So right here, 9 is our smallest side, so 30 degrees would go across from 9. Okay, now that we know how to do the simple Pythagorean theorem, we're going to go to multiple step problems. So for these two, we'll be trying to find the total area for both of the figures. So obviously, to find the total area, you're going to need to find the area for each individual shape and then adding them together. So for the first one, we are going to be finding the area of the triangles, and then finding the area of the rectangle and adding them together, finding the area of the triangle and finding the area of the rectangle, and go from there. Okay, so starting on this one, we know that the side is 8 and the hypotenuse is 10. This is going to be 5, and this side is going to be 8, same as the other side. Okay, so we're going to start off, since we know the hypotenuse, we know the hypotenuse is given, we are going to be looking for this side, which is going to be A. And so we have A squared plus B squared equals C squared. Since we know that since we know we already have 10 as our hypotenuse, we are going to be finding the other side, so we are going to subtract A from both sides, and it'll give us B squared equals C squared minus A squared. So we're going to have B squared equals 10 squared minus 8 squared. B squared equals 100 minus, 8 squared, which is B squared equals 36. B is equal to the square root of 36. B equals 6 inches. Okay, so now that gives us 6 inches. Like that. Now that we have the base for our triangle, we can now find, since we're trying to find the total area of this figure, we can do, we know the formula to find area for a triangle is area equals base times height divided by 2. So this would be, area of the triangle is 8 times 6 divided by 2. 8 times 6 is 48 divided by 2 is 24. So we know that each of these triangles have a total area of 24 inches squared. To find the area of the rectangle, we're going to do base times height. So area of rectangle is base times height. Area of the rectangle, the base is 5, the height is 8. So the area of the rectangle is 40 inches squared. To find the total area of this figure, we're going to add the area of this triangle, area of that triangle, and area of the rectangle. So we have total area is going to be 24 plus 24 plus 40 would give us 48 plus 40, 84 inches squared. So we started out by only having the hypotenuse and finding that smaller number up there. Okay, and for our last problem, we have we know that we have A and we have C, so we're looking for B and then we can find the area of the rectangle with that. So, starting off the same way, a squared plus b squared equals c squared. We already know a, so we're going to have b squared equals c squared minus a squared. B squared equals 17 squared minus 8 squared. So we have b squared equals 17 squared is 289 minus 8 squared, which is 64. B squared equals 225, which we know b would be the square root of 225, which is 15, so b equals 15 feet. So now that we have that one, we can now find the area of this triangle plus the area of the rectangle to give us the total area. So we have area of the triangle would be base times height divided by 2. Area of the triangle. So we have 15 times 8 divided by 2. 15 times 8 is 120 divided by 2. So area of the triangle is 60 feet. So 120 divided by 2 is 60. Area of the rectangle is actually going to be 15 times 8 again, base times height. So area of the rectangle is 15 times 8 equals 120. So we have the total area would be the triangle plus the rectangle, which is 180 feet squared. Started out by only having the hypotenuse and a, so we had to find b and add them two together. Okay, so that is all starting from today. We got familiar with how to find simple Pythagorean theorem, a squared plus b squared equals c squared, and then we put it together to help us find the area of something. Obviously, if I had a class, I would be asking students to come up and demonstrate different parts of the problem on the board. Say I have a student find find A in this problem, and then a different student come up and find the total area, or vice versa. But today was just a simple kind of reminder on how to use the Pythagorean theorem and how to put it into bigger problems like this one or this one. Thank you.